All right, so in this tutorial, I am going to be giving you a rundown of the entire process for creating a photogrammetry asset and bringing it into Unreal Engine 4, setting up materials, doing all of your cleanup in Substance Painter, doing your retopology, and generating your sparse and dense clouds, as well as mesh and textures in Agisoft, and making a game-ready asset from that. I'm also going to be going over best practices for shooting and processing your images, and I'm going to be using this asset that you see on screen as the asset for this tutorial. So as you can see, I'm not using a rock or a tree branch or something like that, which most people like to use because it's the easiest asset to generate from photogrammetry. It doesn't really require a lot of work to get a game-ready asset from. So I decided to use something a little bit more difficult. So this was actually a drinking fountain, and as you'll see at the top, the faucet part of the drinking fountain is no longer there, and the little basin and all that stuff are gone because I manually removed it because it had some issues solving. That's another reason I'm using this, is because I want to show you how to address issues like that and still get a usable asset. So the asset that you see on screen is just under 6,000 polygons in its highest LOD. As you can see, it's already been retopo'd and it's completely game ready. This has 3 LODs. The lower 2 LODs actually just generated in Unreal Engine. As you can see, it has a full PBR texture set, so the water is reflective and shiny as it should be. This little metal plate on the back has its metallic value and it's reflective. And I did all of that in Substance Painter. So if I show you in detail lighting, you can see the PBR a little better. And if I go into unlit, you can see what the albedo looks like, delit, and all of that. Now, as you can see, I didn't go too far with the delighting. This side and this side are still a little darker than the other 2 sides. The reason I did that is because it didn't really make much difference when I brightened that up. And one of the things you need to keep in mind when you're doing asset creation, especially if you're working for a game studio or something with tight deadlines, is the cost to benefit. So cost to benefit meaning not only money, but the amount of time that it takes to achieve a result and whether or not that result is actually going to be beneficial to your final asset. So for this, I didn't think it was worth it to brighten these backsides up. And now one more thing to touch on, I'm only going to be showing you the process for generating your photogrammetry asset in Agisoft Photoscan. All the techniques that I'm going to be showing you in Agisoft Photoscan can be applied to reality capture as well. If you already understand how to use reality capture and Agisoft, then you can figure out how to do the same thing in reality capture that I'm going to show you in Agisoft. And also, I'm using Unreal Engine 4 for the purpose of this tutorial, just because it's my preferred engine, but you can utilize the same processes I show you for any engine, whether it be Unity or CryEngine or whichever one you prefer working in. Everything up until you import it in the engine is going to be the same, and then from there, if you already understand those engines, you can figure out how to apply those to the workflow for those engines specifically. And one last thing is Agisoft and reality capture. There's usually a lot of questioning about which one's better, which one do you prefer using, which can give you better results, etc., etc. So in my experience, reality capture solves more quickly, and it's a more straightforward setup to achieve an end result. But the quality of the textures is usually not quite as good as what you can achieve in Agisoft, and it requires more work to get a level of quality as close as to what you get in Agisoft, at least for the textures. Agisoft takes longer to generate solves, but to me, in my experience, it does a better job. One thing that reality capture is better at is generating solves from a studio environment. So if you capture an object with a camera sphere with a green screen background and controlled lighting and all that, reality capture seems to do a better job and a faster solve than Agisoft does. For exterior, for objects that you shoot outdoors, like this asset, for example, which was in a park, Agisoft seems to do a better job solving and gives you a better end result in most cases. So I recommend trying both for your workflow, see which works better for you, and also check it out per asset and see which one you receive a better result with based on the asset you're actually trying to recreate. So that being said, let's jump into the initial part of the process, which is actually setting up and taking your images of the asset that you're going to be creating. So as you can see on the left of my screen, I have the folder open with all the raw images that I shot for this asset. As you can see, I took 34 pictures. One of the big mistakes that people make when they first start doing photogrammetry is they think they need to take as many images as possible and get as much coverage as possible, but that's actually not a good practice to follow, and it ends up creating more problems for you in the future during your workflow, and it ends up taking longer because you have larger data sets to work through that aren't really adding anything to your final asset. Another thing to keep in mind is when you're taking your images, a good rule of thumb is to try to get a quarter to a third of overlap between your shots. So if you look at my thumbnails, you can see that this was the first picture that I took, and then the next picture that I took, I stepped about 3 or 4 feet to the left and then took another shot. There's around 15 degrees of separation between the images. So you don't have to specifically do a certain amount of steps or anything like that. You just kind of want to eyeball it when you're shooting and make sure you get, about a quarter to a third of overlap between your images. Because what Agisoft is looking for, one of the main things that it does when it pairs these images together before it generates a solve is matching detail between images. So like this image to this image to this image should have similar features that it can correspond, it can correlate the position of those images to. So it's using this plate here in the middle, it's using the texture of the surface, and it's using the silhouette to do that. But one of the biggest things is the feature overlap in the images. So, just kind of eyeball it. And as I said, for this asset, which is probably about 2 feet by 2 feet by 4 feet, I did 3 or 4 steps to the left and then took a picture every time. Another thing that I like to do is I like to do 3 rings when I capture, and then I do some detail shots. So I do a high ring, a mid ring, and then a low ring. And then when I do detail shots, I use it for things, parts of the asset that I think are going to require more detail in the image in order to solve correctly. So you'll see that I took another 8 shots down here of just the top of the drinking fountain, because I knew this, the basin and the faucet and all that stuff were going to require more detail in the frame. So for these, I only took 8 images. So I took 1 at each side and then 1 at each corner. So basically every 45 degrees. And another thing that you'll notice, now that I've gone over, your general setup for the for shooting, is that all of these files are DNG. So DNG is a raw format. It's Adobe's raw format, Adobe Digital Negative, which you'll see over here on the right. I have the site open for, and I'll put the direct link in the description as well. So Adobe Digital, or Adobe DNG converter, which I'll open for you here, looks like this. So it's a free program from Adobe. You can go here and download it, and it'll automatically convert any of your raw files, regardless of what camera they were shot with, into Adobe Digital Negative. The reason I like to do that is because it's the most compatible with all of the Adobe products. So Adobe Digital Negative will work with anything that can import a raw file that's made by Adobe. Some of the other file formats, especially if they're from newer cameras and all that, sometimes you'll have to convert them anyway. So this just gives you a nice standardized format that you can use for your raw files. Now, I always recommend shooting in RAW if you can. If you're shooting on a cell phone, some cell phones allow you to shoot in RAW, some do not. At the very least, you'd want to shoot an uncompressed PNG, but if you have to, you can shoot in JPEG as well if your phone doesn't support either of those. One thing you should do, though, that can really cause issues is you always want to shoot in full manual mode, whether it be on a DSLR or your cell phone. And most modern cell phones you can download an app for, or some of them have it built in natively, where you can control the camera manually. The reason you want to do that is you don't want any of your settings changing, like your f-stop, your ISO, etc., between images for a single asset. So for example, if I shot this fountain and my ISO or my f-stop changed between shots, then when I go to run the solve on it, that's going to show on the asset, so the texture will look weird, the silhouette will actually start having issues because the depth of field will be changing and all that good stuff. So you want to make sure that you always shoot in manual mode when you can. Now the camera that I shot with is a 42 megapixel, which is 7,952 by 5,304 pixels, and it shoots at 240 DPI. And I shot this with a kit lens, which is a 16 to 35. I shot all these at 35 millimeter. I recommend always trying to shoot with somewhere between 24 millimeter and 50 millimeter. Anything wider than 24 or narrower than 50 is going to start giving you issues, and you're going to have to do manual lens correction and all that good stuff, which you want to try to avoid. So I always recommend shooting between 24 and 50 millimeter if you can. Now, when I load up Agisoft, you'll see exactly where my cameras were placed, and you'll see what I'm talking about doing the 3 rings and then the detail shots and all that. So for now, let's load these up into Camera Raw, and I will show you some of the settings I use. Now you can use either Lightroom or Camera Raw, whatever raw editing software you like to do your initial adjustments. I prefer using Camera Raw, which is built into Photoshop, just because it's free and it has pretty much all the same features that you get in Lightroom that you're actually going to use, and it just makes workflow much faster. So let's jump into that. So I have all the images loaded up here in Camera Raw. And as you can see, they're all here on the left, all 34 of them. And if you look down here on the bottom, it shows all of the main meta information for how they were shot. So as you can see, it's using Adobe RGB, 1998 version. It was shot in 8-bit. The resolution is 7952 by 5304, which is 42.2 megapixels at 240 ppi. And if you look over here in the top right, it has the lens information, or what I actually shot it with. So I shot it at an f-stop of 6.3 with 1/640th of a second. ISO was 400, and I used a 16 to 35 millimeter lens, which I had it set to 35 millimeter. Now, if you look over on the right side, these are all the adjustments that I already made to all these images. So you can do modifications to individual images, or you can select all and modify all the images at once. So since I shot all these with the same exact camera settings, and the lighting didn't change and everything was the same, I modified them all at once. So if I go back to the initial settings by clicking this here, go to Camera Raw defaults, this is what the default settings look like. So everything is zeroed out, the temperature is at 6,350, and the tint is at +9. So as you can see, the image itself is much yellower than it should be. I didn't really go in and bother doing white balance and all that because I knew there would be enough information in the raw to pull that back. So the modifications I made, if I switch back to the image settings that I added, I pulled the temperature down more into the blue. I always like to bump up the clarity, vibrance, and saturation, so I do 30, 20, 10 respectively. And as you can see, when I modify the clarity, if I change it to 0, back to 30, you can see that just makes the differentiation between the colors much more apparent. And vibrance, this is different than saturation, but it's kind of like a modifier of saturation, and it bumps up the values in a way that doesn't kind of blow out your image. And then saturation, I just bump up by 10 to bring a little bit of the color intensity back. Now, if you look down here at the resolution and the bit depth, some people like to say, oh, you need to always keep it at the highest resolution and the highest bit depth and all that stuff, but it doesn't usually benefit your end result, especially if you're creating an asset for a real-time engine. You're not going to notice a difference between 16-bit and 5,000 pixels compared to 5K compared to 8K. But you will notice a workflow overhead increase by keeping it at such high resolution. So what I like to do is actually try to restrain my images, or constrain my images to a maximum pixel height or width of 5,000 pixels, and I keep my bit depth at 8. And I don't change the PPI though, because you want to keep your pixel density. So I'm going to load one of these into Photoshop. Okay, so now I've got the image loaded into Photoshop with all the settings that I set up in my Camera Raw. And if I go over here on the right, you can see I already have an action set up to do this. So normally I would load 15 to 20 images at once, and then I run it through these actions. And I also have a save and close action that I put on here, but I deleted it just for the purpose of this tutorial. So that way it'll automatically apply all of the the image size and the shadow and highlight adjustments that I make, and then save it as a PNG a PNG, and then close the file. So I like to save my files as the actual working files that I bring into Photoscan or Agisoft. I like to save them as uncompressed PNGs with a maximum pixel height or width of 5,000. So if I go into image size and adjust the size here, you can see it's still at its raw pixel width of 7,952. So I would make that 5,000. If you shot in portrait, then your height would be 5,000. You just want to make whatever your highest value is 5,000. And then, as I said, I keep the resolution or the PPI at 240, whatever the default raw PPI is. So the next thing I do is I run it through a shadow highlight filter. So this is going to go towards the delighting. Now you can go in and do your own shadow highlight adjustment, but I usually just use the default settings and they seem to work pretty well. So if you go into Image, Adjustments, and Shadow Highlights, these are the default settings. So as you can see, it removes most of the harsh shadowing and all that good stuff. So if I turn it off, back on, and toggle between the two. So what this does is it gives you more of an albedo type texture look to it. And that's what you want, because all of your lighting, your shadowing, your reflections, everything should be done in the real-time engine through the material. So you want your base color to be as shadowless as possible, and let everything else be handled in the real-time renderer. All right, so I'm going to run this action to show you what it does. All right, so as you can see, it did the image size and did the shadow highlight adjustment. So I go into image size. You can see the maximum width is 5,000. And as you can see, it did the shadow highlight. So if I do a step backwards, that's a before and after. So then after this, as I said, I have a save and a close action, and those will save it as an uncompressed PNG, which if you go to Save As, and you select PNG, and then you save it, it's going to give you this dialog. So you don't want any compression, which means you would click None, and then you save the file. And it'll save pretty quickly if you're not using compression. And with these actions, you can also, you can either create an action here and just run it by doing File Automate Batch, and then selecting that action, which you can see it's already selected here, and tell it where to save and all that good stuff. Or you can create a droplet that you can just drag the files into. With raw images, it's still going to bring you through the raw dialog if you have it set up by default. So you want to modify that if you're just going to drag and drop the images in there. All right, so let's jump over into the PNG folder. Okay, so this is the PNG folder. This is where I exported or resaved all of the images as PNG with a maximum width of 5,000 pixels, and I did my delight process on them. So as you can see, if you hover over them, it's got a 5,000 by 3,335 resolution, and the file size is 47.7 megs. So this is going to be a much easier data set for Agisoft to work with, and as I said, your result, at least for real-time engines, is not going to be noticeably different from using higher res or higher bit depth data sets. So this is going to improve your workflow quite a bit. Now, if you'll notice up here, this is the file structure for how I have things set up. So what I do is I like to create a folder for whatever asset it is, and then within that folder I have all my subfolders. So you'll see I have a folder for the PNGs, a folder for the raw, a folder for the actual textures, folder for the meshes, and then these folders up here, these top 4 folders are actually generated by Agisoft. And then you'll see these are the Agisoft projects. So I saved one of each, Align, Dense Cloud, and then the full working project, and then a low poly version, which I'll get to later for the purposes of this tutorial. Normally you would just have 1 or maybe 2 projects in here, and then yeah, you wouldn't be having a separate one for each process in the workflow. I just did this to show you the different steps in the tutorial. So now I'm going to go in and load Agisoft. Okay, so this is Agisoft. If you haven't loaded it before, this is what it looks like. So most of the things that you're going to be doing in Agisoft are going to be near this workflow tab up here. And a few of the things you'll do will be under tools. The very first thing I recommend doing when you load Agisoft, however, is to set up your preferences. So if you go to Tools Preferences, and then you go to the OpenCL tab, you can see that it lists all of your graphics cards. So I have a GeForce 980 Ti and an Intel Iris, which is an integrated graphics chip, which I'm not using. And you'll see down on the bottom it says when using OpenCL, please deactivate 1 CPU core for each GPU in use for optimal performance. So what this means is if you have a 8-core processor, which I have here, you want to disable one of those cores for every GPU that you have. Since I have 1 GPU, I only want to use 7 cores out of the 8. The reason being is that even though most of the task is being run on the GPU, it requires CPU processes to facilitate that task being run on the GPU. So it still needs a free core to allow the GPU to do its job. So I have it set to 7 out of 8 cores because I have a single graphics card. So just make sure you set that up. If you don't have this set up correctly, then your performance is going to be very bad, and it can actually cause crashes. So the Next thing I want to show you real quick before we go to import the images is if you go into View, you have a list of show hide items where you can show or hide cameras, markers, region, trackball, info, or grid. You also have a perspective orthographic switch, which is the 5 key. You can also switch into stereo mode, where it separates the colors out for stereoscopy. You can reset your view, and you can adjust all your your visible panes here. And over here, as you start running through your workflow and you generate your dense clouds, your meshes, etc., all these will become available, and you can switch between which view you want to show in the 3D viewport. And then up here you have your select tools, you have your rectangular selection, you have your circular selection, you have your freehand selection, your move, your rotation, your object rotation, and then over here you have your delete selection and your crop. And then these are just redundancies of your show hide for the most part up here. Over on the left, you have your workspace hierarchy. Now this is going to show all of your cameras once they're imported, and it'll give you information as to whether or not they're aligned, etc. This will show your camera or your images down here, and then this will be all the meta information or the details for whatever you have selected. All right, so let's go to the first part of the process, which is importing the images. All right, so now we're going to import the images. Now in order to do that, I am just going to open the PNG folder, select all the files, and I'm going to drag them in here. Now another way you can do this is by, first I'm going to create a new project. If you go to Workflow and go to Add Photos, you can do it this way as well, and then just select the directory that your images are in, and then you can select all the images together and then import them. Another way that you can do it is by doing the same thing. Go to Workflow and Add Folder. This way you're just selecting the folder that the images are in. And then when you do this, it's going to give you multiple options. So you can either create a camera from each of those images, or you can create a multi-frame camera from that folder. So basically that folder will become a camera, and each image in it will be a different sequence. So if you have multiple cameras and you're recording video, for example, you can record an object from multiple cameras, and each camera will be represented by a folder. You could output the frames from that camera into that folder. So for now, I'm going to create a camera from each file, which is going to be one chunk of 34 cameras. Now, as you can see over here on the left, after I imported them, it says that I have 0 out of 34 cameras aligned, and the NA means that they're not aligned. And down here, all of my my images are located to view. So if you want to, you can also import masks. You can create your own masks for these if you want to go in and path them out or use an alpha channel. So if you right-click and go import masks, you can do that. You can also bulk select and import masks. I would just name them the same name and then give them like an underscore mask or something like that, and it'll assign them correctly. Now, when it comes to masking, for most use cases, it's not really going to be beneficial, especially for the amount of work that it requires. Some people prefer to use them, but in my experience, for most assets you're going to generate, it's not really that beneficial. But it is a feature in here that you can utilize if you're having problems with silhouette carving. All right, so now that all the images are imported and everything's ready to go, we want to start our workflow. So if you go to Workflow and Align Photos, it's going to generate your sparse cloud and put all the images in the correct position. So I've already done that, and I'm going to load that project for you so I don't have to sit through the solve time. All right, so this is after all the images are aligned. Now, as you can see, if I hide the cameras, it's going to solve basically anything the camera sees that it can overlap enough to create a restructuring from. So what we really want to focus on is this right here, which is our water fountain, which is a very small part of what it actually captures. You can see there are points going on almost forever, it looks like. So what you want to do is you want to crop down your sparse cloud, which was what's generated here, and then solve your dense cloud from that. But before I go into that, I'm going to bring the cameras back up. So you can see here the positioning of all of my cameras. Now, as I said before, I normally do 3 rings. For this one, I did 2 rings, and then I did some close-up shots. The reason I did that is because the object wasn't extremely complex, and I knew I didn't need that extra coverage for any reason, and it allowed me to capture it more quickly. So as you can see, I have my top ring, which is just basically eye height, or a little higher, a little lower than eye height, And then I took some more spread out lower images. And then here I took some closer images. These were the 8 images I talked about for just the top of the fountain, because I wanted to make sure I got all that detail in there. All right, so now I'm going to hide these images again, and I'm going to go to the top of the fountain. Since this is more of a square object, I'm going to use the rectangular selection tool to highlight the points. Okay, so that's going to bring it in tighter to the object. So that way, if you keep all these points in here, you run your dense cloud and your mesh and all that stuff from here, it's going to take much longer to solve because it's solving for more data, obviously. All right, so I'm going to hit crop at the top here. As you can see, it cropped it to just those points. Now, since I did it from the top, any points going vertically were going to be inside that rectangle, so it's still got points floating off to the top and all that stuff. So I'm also going to go into the side, and I'm going to crop it down somewhere around there, and then hit crop again. All right, now you can see it's cropped to pretty much the object that we want. We're still going to have to go in and clean up get rid of the ground and all that once it makes a dense cloud and everything gives us more detail to work with. So now that all that's done, I'm going to bring the cameras back up, and I'm going to go to Tools, Reset Region. This will bring the actual region closer to basically the bounding box to the new cropped points. Then what I'm going to do is I'm going to go to Tools and Optimize Cameras. Hit OK. This is just going to optimize the position of the cameras in case there was any shift or anything like that, and it gives you just a better result, and it's more refined. All right, so now that all that's done, we've got everything cropped down to the points that we want. I'm going to go into the next part of the workflow, which is building the dense cloud. So you go up here and you click on dense cloud. So one thing I didn't show you before with align photos is what the dialog looks like. So each of these, when you click it, has its own dialog that pops up. So when I hit align photos, these are the default settings, which I usually keep it set to. But it allows you to modify all these options if you want to. Since we're going into dense cloud, I'll click on that. Same thing, it gives you different options, quality, lowest all the way up to ultra high. I usually keep it at default settings unless I need something extremely high detail or low detail, I just do it there. And whether or not you want the depth filtering to be mild, disabled, moderate, or aggressive. All right, so build dense cloud, so we click on that, run it. Once that's done, it's going to look like this. All right, so the dense cloud has been generated, but we still see the sparse cloud because we have to go up to View and change it to dense cloud. So this is our dense cloud, and you'll see if I zoom in, you can see where the points start separating. The reason you see color is because all the colors from the images are baked into the points, so they're actually just vertex colors, basically. And this is going to allow us to carve out the point cloud and cut our object out of it a lot more easily now that we have all this detail. So what I'm going to do is I'm going to start with the freehand select tool and get rid of this. I always want to get rid of this whole floor down here. So I'm going to start with the freehand select tool and get a good angle to start editing with. So I select the freehand tool, and as you can see, the freehand tool allows you to make freehand movements, but it also has a flat edge on one side. So we're going to utilize both of those. So if we're getting around the base of these rocks, I'm obviously going to use a little bit of a curve to it. So I'm going to go around the edges like this. Obviously, when you're doing yours, you can be more precise. I'm just doing this to show you for the tutorial. And then once you have all the points selected, you just hit delete, and it'll remove them from your solve. So now this part of the floor over here has got a straight edge. So I obviously want to get rid of that, and I'm going to use the straight edge of the freehand tool. I'm going to start here at the very corner of it. I'm going to go out a little bit, and then I'm going to go this way. And as you can see, I'm dragging the straight edge with me, and I'm going to line it up with the the little part of the step here that hits the floor. And then as you can see, it selected all those points. And then I hit delete, and those points are gone. So I'm not going to go through the whole process of doing this, as I think that gives you enough of an idea of how to do it on your own. And you can obviously utilize the the circle tool. You can utilize the rectangle tool. You can select individual points using those as well as if you want to. And then you just go in and cut out any of the pieces that you don't want to be part of your asset. And if you see any smaller pieces like these over here, if they're just hanging out by themselves, then obviously you just want to get rid of them. You just highlight them and then delete them. But really small pieces are going to be ignored for the most part when you generate your mesh anyway. So you don't have to be extremely strict about it, but clean it up as best you can. As you can see here, the whole top of this didn't solve very well. It's missing a lot of pieces, but we're not going to worry about that because when the mesh is generated and we project textures and all that, it's going to fix a lot of those issues because the data is still there in the cameras, but it just wasn't able to restructure it. So as long as you make geometry to compensate for it, it'll project very well. So I'm going to get rid of this basin and the faucet and all that stuff anyway, so I'm not too worried about it. All right, so then once all that's done, you can generate your mesh. So in order to generate your mesh, you go to Workflow, Build Mesh, and then this is the pop-up that comes up. This is the dialog. So you can adjust your surface type between arbitrary and height field. You can adjust your source data between sparse cloud and dense cloud. Obviously, you want to use your dense cloud. You can adjust your final output's poly count, what type of interpolation you use, and what point classes to use. Once you do that, you hit OK, and it'll generate your mesh. And then we'll jump over into what that looks like. All right, so the mesh has been generated, but as you can see, we still are looking at the dense cloud. So I'm going to go to View and then Shaded. So Shaded is going to be your mesh. If I switch over to wireframe mode, you can see the wireframe. And all the color you see, once again, is just vertex color. So if you're in Shaded, all the color you see is just vertex color. So this is not the texture. When you project the texture, it's going to be much higher resolution and all that good stuff because it'll be pixel-based and not vertex-based. So you have different views for your mesh. You have solid, you have shaded, you have wireframe, and then you have textured. So the next part of this is going to be projecting your textures. But before I do that, I'm going to go over one more thing with the mesh. As you see here, it filled in the holes pretty well at the top, but it didn't fill this in. So there are a few ways to go about doing this. Since I'm going to be creating entirely new geometry for these, because it doesn't need, if you go into wireframe, it doesn't need anywhere near this density of polygons for basically a rounded cube for the top and bottom and this metal plate in the back. I'm actually going to go make that geometry myself in Maya, where it's just going to be 2 polys per face with rounded edges, basically a rounded cube. So it'll reduce the poly count quite drastically, and then I'm going to do a lower poly version of these the stone base in ZBrush using ZRemesher. And you can use, if you wanted to, you could go in and auto retopo this with something like Simplygon or ZBrush. But if you want really good results and you want the lowest possible poly count with the best silhouette and all that stuff, it would be better to make this top piece a rounded cube, this bottom piece a rounded cube, and this piece back here, a rectangle without a back face. And then the rest of it you can retopologize however you want. As I said, I'm going to use ZRemesher for that. So the next part of the process is going to be, set it back to shaded, you're going to go Workflow and Build Texture. So with Build Texture, this is the dialog that pops up. As you can see, you can tell it what texture size you want it to be and how many texture sets you want, or how many different material IDs, basically UV splits that you're going to want. And you can have, 4 1024 textures, you could have one 496 texture, you could have a single 8K texture, however you want to set it up. And down here, you can tell whether or not you want to enable color correction. I always just leave it all at the default settings and then just set this to 4K. And for your mapping mode, you can tell it if you want generic, which is what I always leave it on. You can use single camera, you can use all these options here. You can use keep UV. So keep UV is when you import your own mesh, and you want to use the UVs that you already set up on that mesh. If you don't do keep UV, it'll generate its own UVs, and you'll get that output with your texture. And then blending mode, which is mosaic, average, max intensity, min intensity, and disable. So when you go to build your texture, I would recommend just leaving it at these settings unless you have your own mesh. You're going to do keep UV, but we'll get to that part later. So then you hit OK, and it's going to generate your textures, which we'll jump into next. Okay, so the texture is finished generating. So if you go to View, Textured, this is your mesh with the texture projected onto it. Now that you have all of the data that you need to export your mesh and texture, we're going to go to File, Export Model. Select the folder you want to save it into, and I'm just going to give it a fake name, but you obviously want to name it whatever your mesh is going to be. And then I recommend using FBX format. It's the most versatile, most optimized, and it's the one you want to use for your workflow. If you have to use something like an older format like OBJ or something like that, only use it when necessary. There's certain software packages like ZBrush that still require it for import, but you want to try to avoid it if you can. It's not as optimized, it doesn't compress as well, and file size is larger for OBJ format. So I recommend using FBX, and then for your textures, I recommend using PNG. So make sure you have export texture selected if you've generated a texture, and then select PNG, and then once you hit OK, it will export your mesh and texture together in whichever folder you selected. Okay, so now that you've exported your high poly mesh with your high quality texture, we are going to decimate this mesh to a lower poly count in order to retopo it in Maya. So you don't want to bring a 600,000 plus point or polygon mesh into Maya. It's going to bog down your performance. So since we're going to be doing retopo, we just need a guideline for where the surface is of the geometry. So I'm going to go into Tools, Mesh, and then Decimate Mesh. And here it'll give you a target polygon count. So I have it set to 60,000 polygons. So you hit OK. It's going to decimate your mesh. And if you look at the wireframe, you'll see that the wireframe is much less dense than it used to be because it's only 60,000 polygons rather than 600,000 plus. So we're going to export this mesh. We don't have to worry about regenerating texture and all that because we're not actually going to use this for anything other than surface reference. So you go to File, Export Model, and then once again export your mesh, and then call this one Low or Retopo or however you want to name it, because we're going to bring this into Maya to do our retopology. So once you export that, we'll load up Maya. Okay, so I'm actually going to be using Softimage for this part of the tutorial because my Maya is having some issues that I'll have to take a look at later. But the principle is going to be the same. I'm not going to show you, I'm not going to go through the whole thing of creating geometry and all that. I'm just going to show you what I did so you can do it on your own and you'll have an idea of how to set it up. So as you can see here, this is the 60,000 poly mesh that I exported out of Agisoft. And you can see there's polys all over. Even these rounded cubes are using a lot of polygons, which they don't need. So what I did is I went in and I created cubes around those surfaces. As you can see, they're just rounded cubes. And on the back, I made this plate as well as a single surface. It's basically just a rectangle with no back face to it, which you can see on the inside of the mesh. And the reason I'm using the original geometry for guidance in here is because when you go to project your textures, you want to make sure that your new geometry is as close as possible to the surface of the original geometry. Now, obviously, you'll see there's some distortion here where the edges of the original geometry were kind of bubbled out, but we want to make the surface flat on the actual retopo geometry. So instead of having this rounded bulb up here, it's going to be a flat surface with rounded corners and all that. So that takes care of those rounded cubes, and then this part, this stone center portion of the drinking fountain, I'm actually going to use ZBrush to retopologize using ZRemesher and get rid of these cubes and then bring that in here and then add that into the 3 cubes that I've set up here to make the geometry extremely optimized. So let's jump over into ZBrush. Oh, and another note before we jump into ZBrush. When you bring your model in that you're using for surface reference, do not rotate it, change its scale, or anything like that. You want it to stay the exact same that it was when it came out of Agisoft, because when you bring it back in, it needs to be in the exact same position when you project your textures. So you can do all of your scaling and repositioning and all that stuff after you've already got your game-ready mesh with the textures projected and all of that. So in here with these cubes, I didn't actually create any UVs. I'm going to let Agisoft do all that and make it a lot more automated and straightforward. All right, so now let's jump into ZBrush, and I'll show you how to retopologize this base. Now, before we jump into ZBrush, real quick, I want to show you what I did. So I went back to the dense cloud in Agisoft, and I removed all the sections of the mesh that I already retopologized using the rounded cubes. So it's literally only this main part of the water fountain with the stones that I kept. So I got rid of this cube down here, the whole main block at the top, and this panel here. And then I regenerated a mesh from just this part. And then I'm going to export this and then bring this into ZBrush to do my Zremesh on. So if you look at it in wireframe, you can see it's still a high poly mesh. So you just export this as an OBJ this time because that's what ZBrush requires to import, and then you load up ZBrush and run your Zremesh on it. So let's jump into ZBrush now. All right, so this is ZBrush when it first launches. So the first thing you want to do is get rid of Lightbox. You want to go over to Import, and then you want to navigate to the folder where you exported the mesh that you're going to retopo. In my case, it's going to be base high, the one that I just showed you in Agisoft, where I cut out the cubes and the flat surfaces that I already retopoed. And you're going to open it. Now what it's going to do is generate a tool for you. So it'll automatically select it as your main tool, so all you have to do is draw it out by left-clicking. And then by default, it's not going to be three-dimensional until you hit T on the keyboard, and then you have a three-dimensional object that you can rotate around. So once you've done this, you can now go in and Zremesh your surface. Now Zremesh is an automatic retopology tool in ZBrush. Now keep in mind, anything you bring to ZBrush, it's going to lose its UVs. You can do auto UV generation in ZBrush, but I recommend letting Agisoft do it when you bring it back in rather than doing it here. So if you go into Polyview, you can see what the density is now. So what I'm actually going to do is I'm going to make it even more dense. It's currently 24,000 quads, which means it's close to 50,000 polygons, because when it or 50,000 triangles, which is what's going to be used in your real-time engine. So you have to keep that in mind. Whatever it shows here is going to be double that in your real-time engine, because it's going to split all those quads into triangles. So I'm going to subdivide it down by hitting Control-D. As you can see up top, the active points is increased. Every time you subdivide, it's going to go higher. So I'm going to do it to around 2.28 million, which is going to be a subdiv level of 4. So you can scrub through your subdivision levels all the way back to the original one you had and all the way back up top by going into the geometry tab here. And I'm going to delete lower because I don't need any of those. And then I'm going to Zremesh this, this higher poly subdivision level that I did. The reason I subdivided is because it's going to give me a little bit cleaner detail and just make a better Zremesh. So in order to Zremesh, you go into Geometry again and you expand ZRemesher. Now down here you have all of the options for your ZRemesher. You have your target poly count. Once again, this is going to be quads, so you want to make this half of whatever you actually want your poly count to be. Adaptive I usually disable because it kind of gives you its own poly count based on what you input. It doesn't give you exactly the number you want. So if you uncheck that or you unselect it and then you put in your poly count, it's going to be more accurate. So for this, since I want the entire mesh to be under 6,000 polygons, I'm going to run this at a lower level. So I'm actually going to make this, say, 2,500, so 2.5. So everything here is 1,000. So 2 is 2,000, 4 is 4,000. So 2.5 is going to be 2,500. So once I enter that in, I'm going to click ZRemesher, and up here you'll see the progress at the top left. For this, it should be pretty quick. It's not too intense of a, not too detailed or intricate of a geometry. All right, so ZRemesh is completed. Now, as you can see, it made a much lower poly surface, and it actually has really good edge looping and all that good stuff. This is probably the best retopology tool that I've used as far as having really great surface reconstruction. So if you look at the lines that it made, edge looping and all that stuff is really well done. Now, if you want to get a different variation of this and see if it can do a better job, another thing that you can do is, if I do a step backwards, if you hold Alt and click on ZRemesher, it's going to use a different method of retopologizing, which it's doing now. Sometimes it'll give you a completely different result that'll look better. Sometimes it'll look pretty similar to the standard Zremesh reconstruction. So it's worth testing to see which one gives you a better result, and yeah, it'll just give you a better it'll just give you a better all-around end result if you mess around with it and find out which works best for your geometry. All right, so now that's done, we can see that this is our low poly mesh. It has a total point count of 2,849, which is going to be double that in the final geometry, and the cubes that I made are very low poly, so altogether this is going to be a little under 6,000 polygons. All right, so now that's generated, we can look at the poly view. All right, so now I think this is going to be good to go, and we can reproject, we can use this and reproject. All right, so now I think this is going to be good to go. So now we can export this, and then use it to complete our low poly mesh, and then bring it back in Agisoft and project the textures and all that good stuff. Now, another thing you'll notice is there are some holes up here, which you can do fill holes if you want to in ZBrush. For this, I would probably just rerun Zremesh and let it do its thing to fill those in. If it doesn't, then you can do fill holes. So if you want to fill the holes, you can go into Geometry, and then you scroll down and click on Close Holes. Now, if you do that, it's going to close all the holes in the entire mesh, which we don't want. So I would just leave it as is or rerun the ZRemesher until it fixes those holes. For the purpose of this tutorial, I'm not going to worry about it, but keep that in mind when you do your Zremesh. Another thing you can do is Dynamesh and then Zremesh on top of that, but that's also going to close all of your holes. And I want to keep the top and bottom of this and this side panel open. So I'm going to leave it as is for the purpose of this tutorial, and then I'm going to export it, bring it into Maya, and combine it with the rounded cubes you already did. All right, so in order to export it, you would scroll up to the top, go to Export, and obviously select where you're going to export it to. And once again, ZBrush uses OBJ as its default format, so you're going to have to work with that until you export your combined mesh, which should be an FBX. So you would save, and then load your OBJ into Maya. All right, so now we go back into Maya, or in my case, Softimage, because my Maya is giving me issues at the moment. And you can see I've already imported the mesh that I exported from ZBrush that I retopologized with Zremesher, and I've merged it with the 3 cubes that I created for the flat surfaces in the asset. So everything is ready to go. As you can see, I haven't rescaled, rotated, or anything from how it was when I exported it from Agisoft. You want to keep that all in the same place until you, as I said, you reproject your textures in Agisoft, or else it's not going to know what to reproject its textures onto. So once you've done all that, you obviously want to name your mesh appropriately, and then you want to export it, and then you want to bring it back into Agisoft and project your textures. So let's jump back into Agisoft, and I'll show you how to go about doing that. Okay, so now I'm back in Agisoft, and what you want to do is import the retopologized mesh that you just exported from Maya, or whichever 3D package you're using. So in order to do that, you would go to Tools, Import, Mesh. And then you would select the mesh that you just exported. And then you'd hit Open, which I'm not going to do for the sake of this tutorial, but once you do that, it'll import the mesh for you, which I've already done. And as you can see, if I go into Wireframe, it's the retopologized mesh that's just under 6,000 polys. And if I go into Workflow again and hit Build Texture, now, as I said, you can generate your own UVs if you like in Maya or whatever 3D package you're using, and then project onto those, or you can have Agisoft generate them for you. For the purpose of this tutorial, I'm going to have Agisoft generate the UVs for me, but if you import a mesh with your own UVs, then when you go to build your texture, you want to make sure that mapping mode is set to keep UV. This will keep the UVs that you already have on the mesh that you imported. Once you do that, you would hit OK. And then this is what the mesh will look like. So this is a mesh that's just under 6,000 polygons with the 4K texture projected onto it. So now that we have the mesh, which, by the way, I did not change any of the scaling, any of the positioning, or anything of the original mesh, because if I did, you wouldn't be able to reproject the textures on it, because Agisoft will not know what the positioning of it is. So I did not change any of those values since I exported from Agisoft. All I did was lower the poly count and retopologize the surface, all that good stuff. But I kept it within the same area of the original surface. So now that you have your game-ready mesh along with your newly created UVs done by Agisoft, you go to File, Export Model. Then once again, you would select a name for it, and make sure Export Texture is enabled just as before. Select PNG, and then export everything. And this will export the mesh that you have in there now, your retopologized mesh, along with its texture based on its new UV. So you would hit OK. So now we're going to jump over into Substance Painter, where I'm going to show you the next part of the process. All right, so now we are in Substance Painter. The best way to think of Substance Painter is Photoshop in 3D. But rather than just allowing you to paint, certain colors at a time and certain texture at a time, it allows you to paint full materials at a time, so a texture set. So you can paint your roughness, metallic, and normal all in one go. And it also has materials that you can apply directly to objects. It has masking, procedural material generation, and a lot of really cool advanced features. I'm not going to touch on most of those for this tutorial. I'm just going to show you how to use it as it pertains to photogrammetry asset creation. So what you want to do is go to File, New, and you're going to select your mesh. So this is going to be your game ready mesh that you still haven't rotated or done any scaling or anything to. So in my case, it's going to be drinking fountain 001 low. And then here you can add any other assets you want to bring in with it, such as textures. So I want to go in and bring the texture along with it. So the texture that I generated earlier is going to be this one right here. So this is the albedo. And the document resolution, all the default settings and everything are here. So Substance Painter is a non-destructive editor. So regardless of what resolution you're working in, you can always go back up to the maximum resolution without losing any of that information. So I recommend working in 2K, and then before you export, bump it up to 4K, because working in 4K can bog down your system, even on high-end systems. So normal map format should be set to DirectX. Your template, I always use Unreal Engine 4 regardless of which engine I'm actually exporting to. But it has options for a bunch of different templates in here. So I'm going to set it to, or leave it at Unreal Engine 4. Normal format is DirectX. Compute tangent space per fragment. All that stuff is default. I'm going to hit OK. All right, so as you can see, it loaded in the mesh. And over on the left, you can see your material ID. I didn't actually give this one a name, so it's just the default material name, but it will bring in whatever material name that you give it. And if you have multiple materials, you can show hide based on those materials if you like. So by default, it gives you just a standard layer here. We're going to delete that, and we're going to do a new fill layer. Now for this fill layer, we're going to disable everything except for color. So this layer is only going to be adding color into the layer stack, or into the material as a whole. And then since we imported that albedo texture, we can go to click on base color, and then do a search for albedo, and the texture I want is right here. If you hover over it for a second, I'll give you a higher quality preview. So we want to click on that. Now, as you can see, it applied the albedo that I created to the mesh. And you'll see that it's still glossy and all that because we don't have a roughness layer, and it's just defaulting to 0.5 out of 0 to 1. So we're going to fix that. We're going to fix that afterwards. So I want to name this layer albedo. Okay. Now the next thing we're going to do is we are going to generate the normal and AO from the high poly mesh. So in order to do that, you would go into your texture set settings, and which is over here, and you would scroll down. Now I only have this layout because I'm using a single monitor to record for this tutorial. I actually normally have the palettes and all that stuff on a separate monitor, but just so you guys can see everything, I have it all scrunched in here. So you would go to your texture set settings, click on Bake Textures. Now you can do this process in XNormal as well, which I'll show you also, but I prefer to just do it all in Substance Painter. It seems to be faster and gives pretty much the same results. So by default, you're going to have everything selected here on the left, but we only want normal and AO. So I'm going to click on None, and then I'm going to check normal and AO. I want its output size to be 4K to match the albedo texture. And then you want to select your high poly mesh. Now you could bake from your low poly to your low poly for AO if you like, and it actually gives you pretty good results most of the time. But if you do have a high poly mesh that you have all the details on that you want to bake down from, then that's obviously a better thing to do. So you click on this button here and select your high poly mesh. In my case, it's Drinking Fountain H. And I'm going to delete that because I already had that in there. So you would add your high poly mesh in here, and then down here you can either bake all, or it'll only bake for the material set that you, or the material ID that you have selected. Since I only have one material ID, it's only giving me this option. So once you have all that set, your AO, your normal, you have your output size to 4K, and you have your high poly mesh uploaded, then you can hit Bake Materials. And it's going to go in and bake your AO and normal, which is actually a very quick process. It's quicker than what XNormal does most of the time. All right, then it'll say baking finished. Now, if you look down here back in your texture set settings, you can see you now have a normal and an AO, which is automatically populated from what it generated. So if you click on the X, you can see the difference that the normal map makes. Put it back. Add it again. Put it back. Okay, and then if you hide your AO, you can see the difference that makes as well by clicking on the X. Control Z, bringing it back. So as you can see, it makes quite a bit of difference on the surface, and you definitely want to do that for your meshes as part of your PBR workflow. Now, another method of doing your high to low bake is using XNormal, which is also a free tool, and I'll include the download link for that in the description as well. XNormal looks like this. So it's a little less user-friendly as far as the UI goes than Substance Painter, but I will give you a rundown of how to use this as well, because some people won't be able to purchase Substance Painter or will prefer to use this. So the first thing you want to do is go into your high definition meshes, and you want to select the high-res meshes you're going to use. So if you have any in there, just right-click and remove. Then you can right-click and add mesh. So I'm going to go over into my mesh export directory, and I'm going to import drinking fountain 001 high. And then you do the same thing for your low mesh, and obviously you import the low mesh. Now make sure, once again, that your meshes are in the exact same position in the scene. So this is before you do any rotation or scaling or anything like that. So you go right-click and you add mesh. And then mine is going to be L to proj, low to project. And then if you go into your baking options, you have all of the options that you can bake out from XNormal. So if you do want to do a height map, you can have that checked. You can do ambient occlusion, all that stuff. So I'm going to uncheck height map and just do normal and ambient occlusion. You can select your output size. Right now it's set to 4K. And you can select your renderer. Now keep in mind, some of these renders work with some maps and some work with others. So you can test and see which work better. Default bucket renderer works with everything. CUDA is faster, but it only works with certain maps. I don't remember exactly what they are, but you can go through and test it. So I'm going to leave it set to default, and I'm only baking ambient occlusion and normal. So then you also want to select your output directory, obviously. So I'm just going to hit desktop for this one, and I'm going to give it a name. Call it DF. And then obviously the file type that you want it to export to. And as you can see, you can do PNG, BMP, pretty much all the main image formats. So once you've done all that, then you can go to generate maps. And what this is going to do is it's going to compare the surface differentiation between the high poly mesh and the low poly mesh, and then generate the normal and ambient occlusion, whichever maps you have selected based on that. So as you can see, it just finished generating the normal map. Now it's saving it. The AO takes longer, as you can see here, and I'm just going to skip the rest of this, but you get the idea. So once it's out, put your AO and normal textures. You can bring those into Unreal Engine, or you can channel pack the AO with roughness metallic yourself using Photoshop. So that pretty much covers everything with XNormal to generate your high to low bakes. So once all that's set up, now we want to go in and we can finally reorient the mesh, because we're done using all of the positional relationship that it had with what we exported out of Agisoft. So now we can save this and we can go back into Maya, or as I said in my case, Softimage, because my Maya is having issues, and then we can reorient, scale, and position this exactly how we want it to be. So let's jump back into Maya. All right, so now we are back in Maya, aka Softimage. So I've already gone through and scaled and reoriented the mesh, so it's going to be ready to bring in Unreal Engine once we're done cleaning it up in Substance Painter and doing our PBR modifications to it. So what I did is I basically just centered the translation gizmo to the center of the polygons. I rotated it around and I moved it over into the very center of the scene. So as you can see, this is the top view, this is the front view, this is the right. This is our perspective view. So I'm using the front, as you can tell by this cube, I'm using the front as this part here that has the step on it. So I'm using the step as the front of the mesh. And then I'm orienting everything around that. You'll see that there is a slight tilt to it and all that. That's actually in the object that I captured in the real world. It's got a tilt to it, and it's all, it's not all, perfectly aligned. Now I also set this to about 4.5 feet tall, just guessing the height. If you wanted to, you could, measure the object, obviously, after you capture it and save all the measurements if you wanted to get it exact to scale. But for the purpose of this tutorial, I just guessed that it was around 4.5 feet tall. All right, so now what you want to do is export this. And one thing to keep in mind is if you're importing into Unreal Engine is going to set the root of this object to wherever the center of the scene is. So I put the base of it right at the center of the scene, horizontally and vertically. and then I dropped it a little bit below it because it's gonna, it's gonna sit below the surface a little bit. So now that all that's done, you want to make sure you also freeze all of your transforms. You can see everything, scale is set to 1, rotation, transform, all that is set to 0 after I moved it around. So that way all that stuff converts over into Unreal Engine. This would be the same in Maya or whatever 3D package you're using. So then once all that's done, you would go and export it out as an FBX, and then we're going to bring that back into Substance Painter to finish our cleanup and PBR painting and all that good stuff. So now we're back in Substance Painter. So what we want to do is import the newly oriented and scaled mesh and replace this one with that. So in order to do that, you go to Edit, Project Configuration, you hit Select, and then you select the mesh that you exported from Maya. So in my case, that's Drinking Fountain 001. And since it's going to be completely different positioning and all that stuff, you want to uncheck this Preserve Strokes positions on mesh. And another thing that I did that I kind of messed up on when doing this tutorial is I didn't give it a material ID that matched the unoriented mesh. So you want to make sure you do that as well, so you don't have to worry about reassigning your layer, which is not that big of a deal since we haven't really done any work with the layers yet. So I'm going to uncheck Preserve Strokes Positions on Mesh, hit OK. Now, as you can see, it brought in the newly oriented and scaled mesh. And I'm going to have to go in and reassign these normal map and or the normal map in the AO. So click on normal, and then you click on ambient occlusion. And all right, now those are reassigned. And then we need to recreate our albedo texture layer. You won't have to recreate these layers, as I said. If your material IDs match, it'll just automatically keep those layers attached to that material ID. So once again, we're going to unselect everything except for color, change our base color to Drinking Fountain. And there we go. So this is our newly oriented and scaled mesh with the texture we created earlier applied to it. Now, as you can see, one of the biggest issues with this is that this water fountain basin is still projected on there, even though the surface is flat. And we want to get rid of that and just make it a solid piece of concrete. So what I recommend doing is before you start doing any editing, make sure that the viewport looks how you want it to. You want it to be as neutral as possible, so when you're doing your editing, you don't see any color values affecting it from your Sybil, which is your image-based lighting and things like that. So what I like to do is go over to under Viewer Settings and change my environment map to Studio 2, which is a default Sybil or a spherical image. And then if you hold Shift and right-click, and then drag, you can actually rotate the position of that image sphere to adjust your lighting. So I want to position it in a place that I like, which is here. And then what I want to do is use Clone Stamp to get rid of this this basin that's being projected on the top. So I'm going to name this layer once again to albedo. And then I'm going to create a new regular layer. So in order to do that, you just click on this Add Layer button. And I'm going to call this patch. You can call it whatever you want. And I'm going to use this as my clone stamp layer. So in order for this to work, you need to create a regular layer above your the fill layer that you want to clone from, and you select its blend mode and you change it to pass through. So what this is going to do is it's going to pass through any changes that you make on top of the other layer. So go over to your clone stamp tool, which is up here. And then a few more tips is if you hold Control and then right click and you move the mouse up and down, it's going to adjust the softness of your brush. And you can obviously bump up the size of your brush with the left and right brackets, just like you would in Photoshop. So those are the only two things you really need to know for doing clone stamping. So the next thing you want to do is you want to select your sample location, just like you would in Photoshop. But rather than hitting Alt like you do in Photoshop, you hold V and you click on an area, and you'll see that that square showed up. That's going to be your sample location, and you can set it to be relative or non-relative to the position of your cursor. But once you start painting, it's going to be relative to it. So I'm going to start going in and painting. Do the same thing over here. You want to make sure you select, an area that makes sense for where you're painting over. So you don't want to, select from this side and start painting over here. It just doesn't look right. So you want to blend it in really well. So you go in and you cover up that whole thing using this method. Obviously, you're going to have to adjust the scale of your brush as you go along to make sure you don't paint over or select a larger source than what you need. Okay, so obviously that's pretty rough, but you get the idea. You want to go in and blend it, make your brush size larger, get different sample areas, and just kind of blend it in. Make sure there's no repetition, and just clean it up and make it look authentic. So once you're done doing all of that, that'll clean up the texture projection issue that you have. And another thing that you'd want to do is, or at least something that I like to do, is I like to go in and sharpen the texture just slightly. And I do that in Substance Painter because you can actually see what it looks like in real time in 3D on the mesh. So in order to do that, you select your albedo layer. And then you click on the little icon here, which is Add Effect. Click Add Filter. And then as you'll see, it says Filter Empty. So in order to add a filter, you click on Filter down here under Filter. And then you want to find Sharpen. So just type in Sharpen. And you can see there are two versions of Sharpen. We use this one on the right because I'm not sure what the difference between the two is. And then, as you can see, it sharpened up our surface. But we don't want it to be that sharp because that doesn't look very good, right? So that's without sharpening, that's with. So the default setting for sharpen intensity is 1. We're going to set that to 0.25. Okay. So now if I disable it and then enable it, you can see it's very subtle. And keep in mind, I'm still working in 2K, so once I bump it up to 4K, it's going to look even better. All right, so that is the initial setup for our albedo texture. And also, if you want to go and do some more advanced delighting, you can do that as well. All right, so now we're going to do some more advanced delighting in Substance Painter. Now, in order to do that, we have to create a curvature and world space normal map. So we don't really have to worry about what those maps look like. They can just be based off of your low poly mesh. We just need them in order to do the delighting I'm going to show you. So once again, we go into Bake Textures. Uncheck everything except for your world space normal and your curvature. And then, rather than using this mesh, which is the high poly, I'm just going to select use low poly mesh as high poly mesh, and then bake materials. Okay, so once that's done, you'll see that world space normal has been populated and curvature has been populated. So in order to generate your delighting, you want to select your albedo layer, go back up to Effect again, or Add Effect, go to Add Filter, and then for your filter, you want to select Baked Lighting. Once you do that, it's automatically going to populate with your curvature, world space normal, etc. So what this is doing is it's basically baking light into your albedo. So you can use that for delighting to compensate for shadows and all that good stuff. So if I disable it, enable it again, you can see what it's doing. So what I want to do is change the position of this, this light. So you can adjust the sun intensity, adjust its angle, all that good stuff. Now, if you position all this correctly, use the correct colors, intensity, and things like that, you can compensate for shadows if they still exist on your surface. Now, obviously, we wouldn't want to do this to the entire surface. We only want it to affect the areas that are darker than what we want. So in order to do that, what I'm going to do is actually make a duplicate of this albedo layer. Okay, and this duplicate is only going to have the baked lighting on it and the sharpening. The other one will not have baked lighting. So I'm going to get rid of baked lighting from the original one, and this one I'm going to call albedo relit. And then this I'm going to apply a black mask to. This is going to completely mask it out, so nothing from this layer is showing unless I tell it to. And then I'm going to go in and start painting the mask into this layer. So you want to make sure when you're painting that your color is set to white. White is going to show, black is not going to show. So we want to go in and paint just this area that's darker into the mask. So I'm going to do that now. Now, as you can see, as I start painting, the area is already starting to brighten up because all of that baked lighting is only showing on that surface, and the mask is now coming through. Now this part's going to look darker because I haven't positioned the light and everything how I want it to be, but we can modify that after. I just want to make sure that the area that it's affecting is the area that I want it to affect, and then we can go in and modify all those values afterwards. Okay. That should be good enough for the purpose of this tutorial. I think you get the idea. So you just want to go in and paint the areas where you want to remove shadows from. Okay. So now, if I hide the albedo relit layer and then show it again, you can see the difference in brightness. Now, something that's doing that we obviously don't want to do is it's changing the color. So we're going to go in and change the color of the lighting and all of that good stuff to make sure it matches everything else. So light 1, I'm going to make sure it's set to 0. 2 set to 0. Okay, so the only light affecting it is going to be the sunlight. So I'm going to adjust the sun color, and I'm going to match it as close as possible to the color of the default lighting on the surface. I'm going to adjust the sky intensity and the sky color as well. Because what we want to do is we want to brighten up the areas, but we don't really want to change the color too much. Adjust the intensity a little bit as needed. Okay. All right, now as you can see, you can go in and fine tune it as much as you want, but this is before we did any delighting. As you can see, the backside is a lot darker, and this is afterwards. It brightened up that backside a lot and makes it look a lot more like a consistent albedo with no shadows all the way around. So, you know, go in, fine tune it as much as you want if you even need to use this, this part of the process, but that's how you do it. Now keep in mind, I didn't use this process for the final asset. I'm just letting you know that this is something that you can do in Substance Painter. And it can come in quite handy if you use it correctly. Okay, so now that's done, let's get into painting your PBR. So we want to go in and make this water shiny, and we want to make this panel back here metallic, and also give it a little bit of shiny value to it, modifying the roughness of it. So let's go in and do that now. Okay, so now we're going to go in and start painting our PBR surface. So we're going to, as I said before, make this water a little bit more shiny. And we're going to add some metallic values and some shininess to this metal panel back here. So I'm going to get rid of this relit surface just for the purpose of the tutorial so it keeps it consistent. Okay, so the first thing you want to do is create an overall roughness. So I'm going to make a new fill layer. And once again, make sure all of the layers that you currently have, all of your albedo, your patch, and your albedo relit, if you're using that, are set to only show color. We don't want it to affect roughness, metallic, height, or any of that. So create a new fill layer and drag it all the way down to the, actually leave it at the top of the stack to begin with. So what you want to do now is uncheck everything except for roughness, because this is going to be our master roughness layer. So as you can see right now, the surface is still shiny. So if you go down here and drag your roughness around, you can see it's affecting the roughness of the surface. So since this surface doesn't really have much sheen to it, I'm going to set it to a higher value. I'm going to set it to 0.8 just for the purpose of this tutorial, because we still want to have a little sheen on the surface, but not too much, because most of these rocks are kind of polished. Another thing you could do is take the albedo, make it grayscale, and modify it to be a roughness mask, but I'm not going to go into that in detail right now. You could, also make that a mask for your roughness layer in here and get some more varied roughness for the entire surface if you want. But this is just going to be our overall roughness layer, so I'm going to leave it as is. Okay, and then name that layer. And I'm going to drag it down to the bottom of the stack because there's no need for it to be at the top, because what's going to happen is any layer above it is going to supersede it for whatever is enabled, but nothing is enabled for roughness above it, so you can put the roughness all the way at the bottom and it's still going to affect the entire surface. So now what we want to do is go in and create a new layer, which is going to be the roughness for our water, which is what we're going to start with. So I'm going to create another new fill layer. Call this one roughness water. And I'm going to drag this to the top of the stack to begin with, and I am going to uncheck everything except for roughness and color. The reason I'm leaving color checked is because we're going to use it as a visual aid for where we're painting our roughness. So I'm going to set it to a bright color like red. I'm going to right-click, add a black mask, which will completely mask it out. And then I'm going to go in and start painting where I want it to show up, which is going to be wherever this water is. So I'm not going to go in and paint all the water. I'm just going to give you an initial idea of how to set it up, and then you can go in and paint the rest of it as you want. And obviously, whatever your asset is, it's not necessarily going to be water, and you can refine it how you like. And I'm also going to set the roughness all the way down to 0. So when I start painting, it's going to be very glossy. So with the black mask selected, you can start painting. So I'm going to shrink my brush down, make it just as big as I need for the surface, and I'm going to start painting. So as you can see, it's already reflective, and I'm using red as a reference for where I'm painting. And then afterwards, we can disable the color channel once we're done painting it in. So you just go ahead and paint it, wherever you think it should be shiny, or however you want to modify the roughness. Same thing as we can go for metallic, which we'll jump into in a minute. So we've got this little pool of water at the top, and it kind of runs off the side and streams down the whole side of the drinking fountain. So what you would do is go in and paint, obviously the whole thing down, which you saw in the final version of the mesh, and then paint all this in, and that's going to be your roughness for the water. So now that we've done that, we can go back to our layer. Just assuming that we painted everything. Go back to your layer, and you can disable color by unchecking it, and you'll see that the surface is shiny. Now, let's say we wanted to add a little bit of a variation to this because it's shinier than we want it to be. It's too consistent. So what you would do is create a new folder. You would drag that roughness water inside of there. And then, obviously give that folder a name just to keep everything organized. So roughness water. And then we're going to copy this mask by right-clicking on it. Going to copy mask. Then we're going to do a new black mask, and then we're going to right-click on that and then paste into mask, which will copy the mask we just made for this one. So for this, I'm going to set it back to black mask for the actual layer. So the folder has the mask that we just painted, and the actual roughness layer has just a black mask on it. So what we're going to do with that black mask selected on the layer is go into Add Effect, Add Generator. Then down here, we're going to click on Generator, and we're going to do MG Dirt. So what this is going to do is it's going to generate a dirt mask for the roughness. So as you can see here, it's still reflective, but it's got a little bit more breakup to it. It looks a little bit more natural. But we want to modify that a little bit. So we're going to adjust the grunge amount, the grunge scale, bring it up a little bit. There, and as you can see, it just gives the water surface much more realism. And it's going to apply over the entire thing. So basically, this MG Dirt is going to apply to the entire surface. So if I get rid of this mask up here, you can see it's doing it to the entire surface. The entire surface is glossy with that MG Dirt mask. That's the reason you create a folder that's masking it to where you want it to be, and then inside of that mask is where it's going to generate its dirt. All right. So we're going to do the same thing for this panel back here. Now, since we just did the roughness, I'm not going to show you how to do the roughness here. I'm just going to go in and paint the mask and apply metallic to it, but it's going to be the same principle. So I'm going to do the same thing back here, but this time I'm going to create a layer that's got metallic and roughness value. So I'm going to adjust my lighting again just to make it so it's full lit. I'm going to create a new layer. This one, I am going to disable everything except for color, roughness, and metallic, at least to start with. And once again, I'm going to use red as a visual aid. I'm going to call this one roughness, metallic, panel. Okay. And then I'm going to give this a black mask once again. And I'm going to go in and paint where this panel is. So if you click somewhere, I'm going to make this a little sharper because we've got a harder edge here. So when you click the first time, and then you hold Shift, you'll see that you'll get a line that allows you to paint in a straight line. So wherever you click next, it's going to draw a line between those 2 points. I'm going to go down here, basically just creating the border around this edge. And that'll fill that in. And I'm going to do the same thing here. Go. So we have a rough border around our object. I'm just going to go fill in this whole area here. Then fill in the little areas here that require a smaller brush. Obviously, you can be more precise in this, and you'll see that there's some projection areas with the textures and all that, but I'm not really going to bother messing with that for the purpose of this tutorial. Okay, so that's going to be our mask for roughness and metallic for the panel. So now what I'm going to do is go in and adjust the roughness and metallic values. So we want this to be shiny, but not too shiny. And we want it to be metallic. I'm going to set the metallic value to a 0.8. Okay. And then another thing I'm going to do is the same thing that I did with the water. I'm going to create a folder. Giving it that same name, drag that layer we just created into it. Going to copy the mask. Going to black mask, and then paste into mask. Then this I'm going to set back to black mask. Add a filter. I'm sorry, I meant to add a generator. Add a generator. Click generator, mg dirt, and same thing is going to apply to this. We're going to go in and modify the values a little bit. Something like that. We can also invert the values if we want to. Okay, so now that that's done, we're going to go back to our layer. We are going to unselect color. And as you can see, we have a metallic reflective panel. And we can still go in and modify it if we want to now that we know what it actually looks like. So, we can adjust the grunge amount, make it shinier, adjust the grunge scale, all that good stuff. All right, so that's pretty much it for Substance Painter. Now that we have everything done in here, we're going to go into exporting the textures, and I'll show you how to set all that up. Okay, so now we're going to go into exporting textures, and the most optimal way to do that and best practices, at least from my experience. So one thing you want to do before you go to export textures is you want to set your texture resolution, your working resolution, to 4K. So in order to do that, you go under your texture set settings, you set your size to 4K. So I'm not going to do it for the purposes of this tutorial, but once you do that, it's going to recompute everything. And as I said, it's non-destructive. So it's just going to recompute everything, and you'll get your 4K textures without any loss of quality. It'll actually improve your quality because you're bumping up to 4K, obviously. So once you do that, you set it to 4K. You go to File, Export Textures. And in here, you want to create your own configuration. So it has a bunch of default configurations. I don't recommend using any of those. I recommend creating your own. And I'll show you why. So I'm going to go to one that I already created. So this is one that I created for Unreal Engine. So I named this one UE4RMAH. So RMAH stands for roughness, metallic, ambient occlusion, and height. So you're not going to be using height for the purposes of this tutorial, but if you are using height, it's already got a setup ready for it. So what you want to do is create your channel setup according to these textures. So any 0 to 1 textures, basically black to white values like roughness, metallic, ambient occlusion, you want to bake into a single channel of a texture. So this texture here is RMAH is actually going to be a single PNG file with the roughness, metallic, ambient occlusion, and height baked into it, which I went into in a previous tutorial that I put up. Your normal is obviously going to use RGB. Your albedo transmission, or your albedo translucency, is going to use RGB for your albedo, and translucency can be your alpha layer, or your alpha channel. So in order to actually create these, you just, I'm going to create a new one for you real quick, just to show you. So let's say this is your new texture export config. So up here, you select what you want to create. So for albedo trans, you want to click RGB plus A. And then for your normal map, you just want to use RGB. And then for your RMAH, you want to use RGBA separated, like this. And you want to name them accordingly. If you click on this little number sign, it's going to give you the default codes that you can use. So you have project, mesh, or texture set. What this is going to do is get the name from whichever of these that you select. So if it's your project, it's going to be whatever the name of your project is. and then it'll be whatever you type in here. So mine, for example, is drinking fountain 001 underscore test. So if you go back to the RMH setup that I have, you'll see that it says underscore albedo trans, and it's using the texture set. So the texture set is this over here. So it would be material underscore albedo trans, material underscore normal, etc. So that's what all that means. So for this, I'm going to use texture set. And then I'm going to copy that into all these. Okay. Then I'm going to do underscore albedo trans, underscore normal, underscore RMAH. Okay. And then this last one down here, I'm going to recreate because it gave me the wrong one. There we go. Okay. So now in order to populate these, you need to tell it what goes where. So over on the left, you have your input maps and your mesh maps. So the input maps are what we're going to use. So base color is going to be your albedo. So you would drag that over into your RGB and then select what channels you want it to fill. So it's going to fill the RGB channels. Your transparency is going to be your opacity, which you would drag into your alpha and say you want it to be the A channel. Your normal map is going to be your normal, which is going to populate your RGB channels for that slot. Your roughness is going to be your R for your RMAH, and you want it to be the gray channel because that's just going to render in the, or it's only going to populate the R channel. Your metallic, you want to drag into your G channel. You basically want to correlate this RMAH with your RGBA over here. So then your ambient occlusion, you're going to put into your blue channel. And then your height, you're going to put into your alpha. And as I said, if you're not using height, you don't have to worry about it. That's just, I'm just giving you an example of a full setup. So once all that's done, you have your texture export config. So then, if you go back, this is the one that I already created, so I'm going to use this, which is the same setup I just showed you. So when you go to export, you want to select that from the drop-down list. So the one that I created is UE4 RMAH. And if you expand this, it's going to show you what it's exporting. So as I change these, you'll see that that changes. Okay. And then up here, it's going to tell you what your document size is. And it'll tell you what you're exporting to, what resolution you're exporting to. So you can change it to any of these resolutions, but it's going to sample it from whatever your document size is. So currently the document size is 2K, so it's telling me that, but you want to use 4K as I mentioned before. Everything else, as far as format and all that you want to leave as default, so PNG at 8 bits is perfect. Your output directory is self-explanatory. You just select where you want to export the files to. And then once you're done setting all of that up, you just hit export. It'll export your textures into whatever folder you selected, and then it'll tell you when it's done. And once it's done, it'll give you the option to either just hit OK to get rid of the dialog, or you can open the folder that you just exported to. So now that all that's done, we're going to bring all the assets into Unreal Engine 4, and I'll show you how to set them up there. Okay, so now we are finally in Unreal Engine 4 where all the magic is going to happen. We're going to put everything together that we just created, and you'll have a game-ready asset. So the first thing we're going to do is bring in the textures, which we just exported from Substance Painters. So depending on where you have them, you just drag them in. So a quick note on dragging assets into Unreal Engine, especially textures, is when you first bring them in, you'll notice a little plus symbol pop up, and you'll see a crossed out symbol, and then the plus symbol will pop back up. You want to wait until the second time it pops up, or else it's not going to get your drag command. It just seems to be an ongoing bug with Unreal Engine, but just keep that in mind, or else you'll be frustrated as to why you can't just import through drag and drop. But you can. So just do that, drag it in there. It'll automatically import your textures. Now, it also automatically recognizes when a texture is a normal map, and I've never seen it fail, but if it does, I'll show you how to modify the texture so it's actually being utilized as a normal map. As you can see down here, it already gave the notification that it was imported as a normal map. Now, if it did not do that, what you can do is double-click on the texture, which is going to bring you this pop-up. And over on the right side, the compression settings, you can change to normal map. This is the default for all textures, but if it notices it's normal map, which it does every time in my experience, then it'll set it to this. So if for any reason it doesn't, you just set this to normal map, and then you click save, and that's it. Okay, so I'm going to delete these textures because I already imported them and have them all set up. And I recommend keeping a very organized structure in Unreal Engine. So as you can see here, and I've mentioned it in previous videos, I have my root content folder because I release assets on the marketplace. This is actually going to be part of a photogrammetry prop asset pack that I'm going to be releasing in the not too distant future, so keep an eye out for that. So I have it named Scene Media, then Props Pack Edition 1, and under that I have all my subfolders. So I have maps, materials, meshes, textures, and under each of those I have all the subfolders for the different categories. So under meshes I have generic, nature, sports, etc. And all these are correlated with what I have under material, instances, textures, meshes, all that stuff. All the names are shared based on those assets. So I've already imported the textures, and they are in my textures structures folder, or structure folder. And as you can see here, I've got drinking fountain albedo, normal, and RMAH, which we just created in Substance Painter. So now what we want to do is import the actual mesh. So I've already got that imported as well, which is right here. So I'm going to show you how to import it, just for your reference. All right, so once again, you could just drag and drop, or you could actually go to the import dialog. So if you click import, and then navigate to where your mesh is, and you double click the mesh, it's going to bring up this dialog. Now it'll automatically detect what kind of a file it is that you're importing and give you the necessary dialogues when you import. So since this is for a static mesh, it gives you all of these import options. So what I normally like to do is I leave it all at default. Sometimes I'll uncheck certain things like combine mesh and all of that. But I'm going to leave it all default for now. I'm going to let it generate light map UVs, etc. But you can go in and modify all these settings, which I recommend going through and see what all these do and get the best options that you want. And if you've already exported multiple LODs, you can import those as well along with the mesh. But I'm going to show you how to generate those LODs in Unreal Engine. So go ahead and click import or import all if you're doing multiple meshes. And since I've already done it, I'm just going to close this out. And my mesh is here. So this mesh already has LODs generated, already has a material assigned to it and all that, but I'll go through and show you how to set all that up. So the first thing you're going to want to do is apply your materials. So now the first thing you want to do is go in and generate your LODs. So as I said in the beginning of this video, this mesh has 3 LODs. So you can see the base LOD. If I go into wireframe, and you can see over here the poly count. So triangles are 9,600 and vertices are just under 6,000. So at the beginning of this video and throughout the video, I think I've mentioned that it's just under 6,000 polys. I was looking at the vertices and not the triangles, so it's actually just under 10,000 polys, which is still extremely reasonable for a mesh of this type. So yeah, just under 10,000 polys. So if I switch over to LOD 1, you can see that the polys drop to 1,900 polys. If I go to LOD 2, you can see it drops down to just under 1,000 polys. So in order to generate those LODs, you want to expand LOD settings, and then you set your number of LODs to the number of LODs you want. I think 3 is a good number. You have your high, medium, and low. So you set that to 3, and then once you change this, it's going to activate this apply changes, right? So you click on apply changes, and it'll allow you to go in and modify those LODs. So since I've already got the LODs generated, I can go to each one. So as you select them here, it's going to populate down here. As you can see, this LOD is changing. You can also change it from this drop down here. So if you want to modify what each LOD is, you just have it selected up here. You can't modify the root LOD, by the way. It has to be one of the LODs that you generated. And then here you can say % triangle. So basically this is a percentage of the original triangles that are going to render for each LOD. So as you can see, I typed in 20. It automatically changed it to 19.9999. But I typed in 20 because I want it to be 20% for the first LOD. And then the lowest LOD, I wanted it to be 10%. So that's pretty much all you do is type in the percentage that you want. You can also change it to, you can adjust your max deviation, pixel error, etc., etc. And then you can modify all this stuff, which I didn't even touch. And then once you select the percentage that you want, as you can see down at the bottom, apply changes becomes available, and you just hit that, and it automatically generates your LODs. And I believe Unreal Engine is still using Simplygon's algorithm, which is also one of the best in the industry. And I I recommend looking into that tool if you haven't already. So once you do that, all your LODs are generated. And if I go back into auto LOD and you pay attention to the triangle count over here, as I pull away, you'll see it drops. And if I turn off wireframe, you can see how seamless it is. You don't even see the polys dropping. So it does a very good job of auto-generating LODs, and yeah, that's pretty much it. So once you have all that generated, you just hit save, and your LODs are set, and it's ready to go when you bring the mesh into your environment. So what I'm going to do now is I'm going to bring the mesh into the scene. You can literally just do that by dragging and dropping. I'm going to set all of its location information and rotation all that to 0, so you just literally tab through it and hit 0. As you can see, it's telling me to build lighting, which I'm not going to do just yet. So when you first bring it in, until you set up a material, it's just going to have the default world material, which looks like this. Those are what the mesh will look like when you first drag it in. Since I already created the material and assigned it, that's why it showed up when I dragged the mesh in. But when you first do it, it's going to look like that. So talking about materials, let's go in and generate a new material for this object. So as you can see, I have a materials folder, and then I have an instances folder with all of the subfolders underneath it. So the materials folder I reserve for my master materials, and then instances are instances of those materials. So basically, you can have a single master material for PBR, and then create instances of that where you can change the textures and values and all that. That way it only loads the master material once, and then it just loads the modifications that you make for each instance, which creates much lower overhead. So you should always be using a material instance rather than a master material for your objects or for your assets. So I'm going to create a new master material. As I said, I've already created one here, but I'm going to create a new one just for the purpose of this tutorial. I'm going to call this test master. The one that I used for this is actually PBR master, but I'll set it up the exact same way. Okay, so now that we've created the master material, which is this test master, you want to double click it to load up the material editor. So what I'm going to do is make a replica of the material that I already created. So the very first thing that we want to do is create our texture samplers. So I've already created what a placeholder texture. So basically when you create a texture sampler, it has to have a texture inputted into it. Even if you go to add textures into a material instance, if you don't have a texture already assigned to that node in the master material, it's not going to work. So I create a placeholder texture for standard color maps like normal, albedo, RAH, and all that. And then I also create one for the normal map, which is compressed as normal. And they're both just 32 pixels by 32 pixels. And you can just assign those to your texture sampler nodes in your master material. So since I've already created them, I'm going to have them highlighted. I'm going to create my texture sample. As you can see here, the texture is already populated because I have it selected in the content browser. So in order to create this texture sampler, you just hold T and then you left click. So I'm going to make 3 of these. You can also create them by right clicking and then typing in texture sample. And you have it right down here. Okay, so I've made 3 of these. Now I want to turn these into parameters that I can expose in the material instance. So I'm going to select all of them. I'm going to right click. I'm going to click convert to parameter. And as you can see here, it has a parameter name as multiple values, all that good stuff. You can call it none1, none, and none2. So all of these are going to start with texture dash. So I'm going to name all of them texture dash to start with. Okay, and then I'm going to assign them to a group called textures. So this group is going to be a way of grouping things in the material instance. Whatever you type in here is going to be populated in this dropdown. So once I start typing more things, you'll see them show up in the dropdown. So each of these now have to have their own individual name, obviously. So I'm going to call this one texture-albedo, RMAH, and normal. Now, as you can see, I named these pretty much in order of how they appear in this root node over here, which is the only thing that shows up when you first create a new material. Now, for some of these values, we can just plug them straight into the texture slots. For The AO, we have to do a roundabout method because AO over here hasn't actually worked in Unreal Engine the entire time I've been using it, which has been ever since it was released, and I'm not sure why they still have it here, because to my knowledge it doesn't work at all. So in order to, you actually have to multiply the texture on top of your albedo. So let's plug in the roughness first, which is going to be the red channel of your RMAH, because it's RMAH, red, green, blue, alpha. We're going to plug in the metallic, which would be the green channel. And then we're not using height, but if you were, you would plug in your height input into the alpha over here and have your node tree set up for that. Then we're going to plug in normal to the RGB of our normal texture sampler. Now, for base color, since we're going to have to multiply AO by the base color to get ambient occlusion, we're going to do an extra node tree in here. So we're going to do a multiply by holding M and then clicking. Then we're going to do a power by right-clicking and typing in power because I don't know what the shortcut is. And then we're going to plug the B channel from multiply into power. We're going to plug the A channel into the RGB of albedo. We're going to plug the base color from the master node into multiply. And then we're going to plug the base of power into ambient occlusion, which is the blue channel of RMAH. So now what we need is an exponent for power to adjust its power by. So we're going to create a 1 vector. So you hold the 1 on the keyboard and left click, convert that to a parameter. This one's going to be called AO intensity. And I'm going to create a new group for this called main. And I'm going to set its default value to 1, which will just be AO at its normal settings, and we want it to show up by default. So I'm going to plug in exponent from power into AO intensity. And then that is our basic material setup. Everything is good to go, and now we can go create a material instance and populate it with our textures and get everything set up. So you just hit save and close out your material. Now, back in the content browser, we have our test master here, which we just finished setting up. So in order to create a material instance, you want to right-click on it, create material instance, and it's going to generate a new file here, and then you can name that whatever you want. I named mine specifically for this asset, and since it's already created, I'm just going to jump over to that. Drinking fountain 001, so as you can see, my material instance matches the name of the mesh, and it also matches the name of the textures that I created, so as you can see, the naming is all consistent. So for the textures, you just add underscore albedo, underscore normal, etc. And this keeps it all a lot more organized. So if you're ever looking for everything to do with a single asset, you can just type it in. And then it brings up all the assets tied to that asset, all of the files attached to that asset. So I'm going to go back to my material instance, which is the one I just created off of the material, the master material that we created. And then I'm going to load that by double-clicking it. Now, as you can see, I've already got it populated with all the textures and all that, but what you would do is by default, when you first load it up, it's going to look something like this. All of this is going to be unchecked. Now you can see these are the groups that are created, so main and textures, and everything is organized underneath that to make it a lot easier to filter through everything. Now this toggle you can ignore. This is something special I created specifically for this pack, and we didn't go over that in the master material, so you can just ignore that. So AO intensity. I'm going to check that. I'm going to check all these textures because I want to replace them. So the textures are over here. In order to put them in there, you literally just drag and drop them. So you drag them into their appropriate slots. So the albedo, the normal to the normal, and the RMAH to the RMAH. Now, as you can see here, I am using, since I have this unchecked, it's not going to let me do it. There we go. So I am using the RMAH texture, which we generated in Substance Painter. So once all of that is populated, you have a fully functional material instance that you can apply to your mesh. So in order to apply it to the mesh, you can select the mesh either in the viewport or in the content browser, however you want to do it. And you can double click the thumbnail if you have it selected in the viewport, which is going to load the mesh editor. And then you want to assign the material. So since we have the material open, I can just click on Browse, which will find it in the content browser. And I can just click this arrow here, which will apply it to the mesh. As you can see, our material instance is now applied to the mesh. Then you just hit save. And the mesh in the scene has been updated with the material instance that we created. Now you can also go in and swap out the material, obviously, per asset in the scene if you want to by doing it here, but I'm not going to go too in depth with that. One more thing that I will go over with the asset creation is your light map density. This is normally something I do when I first import a mesh, but I'm doing it out of order here because I forgot to cover it when we first imported the mesh. So in order to adjust your light map density, if it's going to be a static object, you want to make sure your light map density is appropriate for the asset. So in order to do that, you load up your static mesh again. And then if you go into general settings under your mesh editor, you can see that you have light map resolution. By default, this is going to be set to 64, but sometimes you want it higher, sometimes you want it lower. So in order to visualize this, if you go back into the viewport and your mesh is set to static under mobility, which this one is, and you go under lit and you go into optimization view modes and you select light map density, you can see what the light map looks like. So you can see that the general plane on the floor has a really, really low light map resolution, and then the mesh itself has a high light map resolution. So as I go in and adjust this, you can see it modifying in the scene, or you can see it updating in the scene. That's the default setting. I bumped it up to 85 just to make it a little bit more dense. And it's using the UVs from the standard UVs because I disabled generation of light map UVs, which Unreal Engine will do itself if you want it to, but for this instance, I didn't have it do that. So once you've adjusted your light map resolution, you can hit save. Another thing you can do is reassign the light map coordinate that it uses. Now, light map coordinate index is the UV that it uses. So if you have multiple UVs in here and you want to have one specifically for light maps, you can do that by inputting the number of the UV here. So as you can see, it's set to 0 because there's only one UV, but if you have 1, 2, or 3, you can just put those numbers in and it'll use those for its light maps. Okay, so once you're doing all that, hit save. And now we have a fully game-ready asset from Photogrammetry. As you can see, it's got all of the PBR surface. All that stuff is working how it should, and it looks just like it should. The poly count is low enough for gameplay. It has its LODs. Everything is good to go. Obviously, I need to build lighting, but I'm not going to do that for the purpose of this tutorial. And one more thing is if you want to lower your texture resolution, I always recommend working in 4K, and then you can always change it in Unreal Engine before you actually go to compile your build. So if you go into your textures and you find the textures that you want to change, you can either do it one by one by double-clicking it. And if you go in here, it'll tell you what max in-game resolution is, displayed resolution, imported resolution, right? So if you want to change that, you can actually, under compression, if I collapse all of these, just expand compression, you can see that it has maximum texture size. If I modify this, let's say if I want it to be at 2K instead, I do that and I hit enter, it's going to take it a second to update, but then you'll see that the imported resolution is 4K, but the displayed and max in-game is 2K. So you can go in and adjust all that, and then when you're actually working, it's going to still keep the 4K original texture that you brought in, but what you'll see in your editor and when you build and all that stuff is going to be the 2K or whatever you set it to. So I'm going to set that back to my default. Okay. So there you go. I hope you found this this tutorial helpful, and hopefully you have a really good grasp of how to generate game-ready assets from Photogrammetry now. And if you have any questions, please let me know in the comment section. And once again, this is one asset that's going to be part of a asset pack that I'm releasing of Photogrammetry props that you can use for your games or whatever project you're working on. And it should be available within the next month or so, so keep a lookout for it. And it's going to contain probably around 20 different assets. All right, let me know if you have any questions in the comments once again. And I've put all the relative links down in the description as well as timestamps for everything.